Okay, you're looking at some graphing of some polynomial inequalities. Essentially comes down to factoring, setting the factors equal to 0, then considering the multiplicity of the roots, and whether or not the function is positive or negative. So in this first one, we have a difference of two squares. So that's pretty easy to factor. It's just x minus 3x plus 3, and we'll disregard the inequality statement for a second. Set that equal to 0, I get x equals 3, x equals negative 3. So a rough sketch of my graph is going to have x-intercepts at 3 and negative 3. Since both of these roots have odd multiplicity, that means it crosses the x-axis at 3 and negative 3. And since x squared is positive, you know it's facing up. So therefore our graph looks something like this. Since it's greater than, we have open circles at negative 3 and positive 3. So therefore we're not going to be including those those points on the graph. And we want to know, when is the function positive? Well, the function is going to be positive for these x values to the left of negative 3, and the function is going to be positive for these x values greater than 3. And in between these two, our function values are negative, so therefore we're not going to include the red region in our solution. So therefore, if we want these yellow regions here in interval notation, we would write it as negative infinity to negative 3, or 3 to infinity. Or if you don't like that notation, you could write it x is less than negative 3, or x is greater than 3. So those two solutions are the same. So we continue with another polynomial. I find it easier to have it so that my highest degree term is positive. So I'm going to move the 3x and the 5 over. So I get 2x squared minus 5x minus 3 less than or equal to 0. So I factor this. So 2 times 3 is negative 6. What are the factors of negative 6 that give me negative 5? That would have to be a negative 6 and a positive 1. So therefore I'm going to rewrite it as 2x squared minus 6x plus x minus 3. I'll just make it equal to 0. I'll deal with the inequality later. Factor by grouping, greatest common factor of each pair, gives me x minus 3. These two are the same, so I'm just going to write it as x minus 3. So I take out an x minus 3 and 2x, and there's an imaginary 1 here, so that's 2x plus 1. So my two roots are 3 and negative a half. So again, graphically, I have negative a half over here and 3 over here. It's an upward facing parabola because the x squared term is positive. Since it's less than or equal to, we have the closed circles at negative a half and 3. And so therefore, since we want the function values to be negative, we want this region here in between those two numbers. That is going to be our solution set from negative a half to 3. And since the circles are closed, or since it's less than or equal to, we're going to use brackets. So therefore we'll say from negative a half to 3 is our solution. Or you could write it x is less than or equal to, negative a half is less than or equal to x is less than or equal to 3. Okay, so here we have a cubic, we don't have a quadratic, but the easiest way I find to handle this one is to take out the greatest common factor of x. So that gives me 6x squared plus 19x plus 3. And if I notice, 6 times 3 is 18. Factors of 18 that give me 19 are 1 and 18. So I'm going to rewrite this by splitting the middle term of 6x squared plus 18x plus x. So 19 is 18 and 1 plus 3. Take out a greatest common factor of the first pair and the second pair. So take out a 6, that's a sad looking x. That gives me 6x, Let me fix that. So that's x plus 3. This is prime, so we'll just take out a 1. X plus 3. And factor by grouping, so I have an x up front, and then I have an x plus 3, so that's these two. And then I'm left with 6x plus 1 is less than or equal to 0. So my roots are 0, negative 3, and negative 1/6. So along a number line, I have negative 3, negative 1/6, and 0. And since it's less than or equal to, these are all closed circles, so we're including those points. And since it's a cubic function and the lead term is positive, you know it's increasing from left to right. And since it has to have 3 intercepts, it does a little boop-de-boo, up and down and up and down. Let's pretend that goes through the origin. So we want when the region is less than or equal to 0. So in that case, that's going to be for these x values over here is less than or equal to 0, as well as in between -6, -1, 6, and 0. And since these circles are closed, our solutions will be written in brackets. So this is -infinity to -3, including -3, and we want to go from -1, 6 to 0. Or you could have written it as x is less than -3, or -1, 6 is less than or equal to x is less than or equal to 0. So again, now we have a quartic. Again, I like to keep the highest degree term positive, so I'm going to move that x over. So it's x to the 4th minus, sorry, my computer just paused there. Take out a greatest common factor of x, gives me x times x cubed minus 1 is greater than or equal to 0. This in factored form is x, and then this is x minus 1. If you remember the difference of 2 cubes, you square the first term, square the last term, multiply these two and take the opposite. So therefore, I have these two roots are 0 and 1. I just need to figure out what this root is right here. There's no factors of 1 that add up to 1, so let's use the quadratic formula. I'll write that out now. So here it is by just plugging in the numbers, and if you notice underneath the radical, I get 1 minus 4 over 2, which is -1 plus or minus -3 over 2. And since we're graphing things on the real plane, meaning there's no imaginary shown here, this is an imaginary root, so therefore it's no help. So the only roots we're going to use are 0 and 1. So 0, closed circle, and 1, closed circle. Since it's x to the 4th, it pretty much looks like a parabola, and both of these roots are odd, so therefore it's going to cross through the x-axis. And since x to the 4th is positive, it's facing up. So we want the regions when x is greater than or equal to 0. So that's going to be from here to here is our, oops, sorry, that's wrong. We want to have greater than or equal to 0, sorry. We want to have this region over here and this region over here. So we would write that solution as -infinity to 0, greater than or equal to, so therefore that's brackets, parentheses, brackets, what is that, 1 to infinity. Okay, this one's a little interesting because we have x to the 5th is on the right hand side, so I'm going to move it. I like to keep the highest degree term positive just so I know what the function looks like so I don't mess it up. So I'm going to move the x cubed over. So I get x to the 5th minus x cubed. I take out a greatest common factor of x cubed. That gives me x squared minus 1. So that gives me x cubed, x minus 1, x plus 1. So therefore we have 3 roots where all of them are odd multiplicity, so therefore it crosses through the x-axis at -1, 0, and 1. Since it's greater than in this case, all of these circles are open, where this is the origin here, and it's a 5th degree polynomial that pretty much looks like a cubic because it only has 3 roots, and all of these are odd multiplicities, so it doesn't touch, if you will, any of the x-intercepts. So therefore it's just an increasing function going from left to right. So the easiest way to do this is you read the problem from the function towards the inequality statement. So it's when is this function less than 0? So you read it from the function now towards the inequality. So when is this function less than 0? So that's going to be in this region over here and in between those two right there. So that is written -infinity to -1, 0 to 1, or x is less than -1, or 0 is less than x is less than 1. For our last example, again, my highest degree term is on the right hand side. I'm going to move the x to the 4th over. So I get x to the 6th minus x to the 4th. I take out a greatest common factor of x to the 4th. That gives me x squared minus 1 again. So I factor that, and I get x minus 1, x plus 1. So I have 3 roots here where this one is an even multiplicity. So therefore it's going to touch the x-axis at the origin. So a rough sketch of my graph is going to be at -1 and 1 and this is 0. So an odd multiplicity crosses through these two x-intercepts, touches this one here. It's x to the 6, so it pretty much looks like a parabola, except in this case it has 3 roots, and it touches right here. So therefore it's upward facing, crosses through, touches, and then bounces back up. Let's pretend that this is a nice smooth curve. It wasn't supposed to be a corner there. So we want to know when is the function greater than or equal to 0. So, and since it's greater than or equal to, these circles are all closed. We're including those in those points. So we want to know when is the function positive. So that's going to be in this region over here, this region over here, and at this point right here, only at that point. So we essentially have 3 regions, to the left of -1, to the right of 1, and at the origin. So how do we write that as answer? So it's from -infinity to -1, brackets, or x equals 0, or 1 to positive infinity. Or again, you could write it x is less than -1, or x is equal to 0, or x is greater than or equal to 1. So there's polynomial inequalities.